Hello, this is a video to help you review for your Chapter 7 test. And I'm sorry I made a mistake and I thought I had posted this video, but I actually didn't. So I'm going to make it for you right now today. Let's see. So starting with the first review problem for the Chapter 7 test, it says square root of 20 minus 4x, and it says what is the domain. So we have to take the inside of it, and the inside of a square root is allowed to be greater than or equal to 0. Now we need to get x by itself, so I'll subtract 20 from both sides, and we'll get negative 4x is greater than or equal to negative 20. Then we'll divide by negative 4, then we'll get x, and when you divide an inequality by a negative, the direction of the inequality changes. So this becomes a greater than, the greater than or equal to becomes a less than or equal to, and then negative 20 divided by negative 4 is positive 5. So x is less than or equal to 5 means that x could go forever. Less than negative 5 would be negative infinity. All the way up to and including 5 would be 5 with the bracket around it. So the domain of that is that. And so the graph of the function looks like this. Starts at a 5 and then it heads left like this. Now let's try problem 2. So problem 2 says square root of x squared plus 4x plus 4. So it's a perfect square inside of it. So we can take this square root of the first part and the square root of the last part, and then the sign from the middle, and then put a square on the outside. Now when you take the square root of a square, the square cancels out and becomes an absolute value. So you have the absolute value of x plus 2. Then problem 3, it says to rewrite 343 to the negative 1/3 power. And that means that when you have a negative power, it brings it to the opposite side of the fraction. Either the top becomes the bottom or the bottom becomes the top. So it's going to go to the bottom, and then the sign of the exponent becomes positive. Now, we need to simplify that. So this is the first part of the answer. Then we actually have to do it. So the cube root, so 1/3 power means that you take the cube root. And the cube root of 343 is 7. So this equals 1 over 7. Now let's try problem 4. So problem 4 says x to the 1/3, y to the negative 3/5 to the power of 1/5. So when you have a power on the outside of the parentheses of some other powers, you have to distribute this power to the powers inside. And 1/3 times 1/5, 1 times 1 is 1, 3 times 5 is 15. And then with the y, negative 3 times 1 is negative 3, 5 times 5 is 25. Now we're going to rewrite it. We'll leave the x to the 1 over 15 on top, x to the power of 1 over 15, and then we'll bring the y down to the bottom so that its negative exponent will become positive. So that's your final answer. Now let's try problem 5. So problem 5 says 25th root of x to the power of 5. Well, that equals x to the power of 5 over a root of 25, and that fraction reduces by 5 to be 1 over 5. And then x to the 1 over 5 means the 5th root, so that equals the 5th root of x. Now let's try problem 6 on the review. Problem 6 is a 7th root of x squared times the square root of x. So the first thing we do is remember the 7th root of x squared can be written as an exponent of 2 over a root of 7 times x. Square root of x is the power of 1 over a root of 2. Now we get a common denominator of 14. So multiply this fraction by 7 over 7, and this one by 2 over 2. Then we'll get x to the 4 over 14 times x to the power of 7 over 14. And when you have two letters that are the same letter multiplied together, then you add the exponents. So this equals x to the exponent of 4/14 plus 7/14, which is equal to x to the 11/14, which that equals the 14th root of x to the 11th. So that's the answer. Now let's try problem 7. Problem 7 says cube root of 81 x to the 4th y to the 2nd times cube root of 9x y to the power of 9. So when they're in the cube root, you can join them all together because both of them have a cube root around them and they're multiplied. So you can join them together into one long cube root. 81x to the 4th y squared times 9xy to the 9th. Now that they're together, we have 81 times 9, which I'm going to write this 81 as 3 to the 4th power, and the 9 is really 3 times 3, so it's 3 to the 2nd power. And then I'll add all the exponents together. So 4 plus 2 is 6. So this equals the cube root of 3 to the power of 6. And then x, this x right here has a power of 1. And 4 plus 1 is 5. So x has a power of 5 when I add the exponents. And then y, 2 plus 9 is 11. So y has a power of 11. Then let me write the exponents as fractions. So that equals 3 to the power of 6 over root of 3. X to the power of 5 over root of 3, y to the power of 11 over root of 3. Now 6 over 3 is 2, so that equals 3 squared. I can break apart the x to the 5/3 into x to the 3/3 and x to the 2/3, because there's 5 total. And then the y to the 11/3, I can break that apart into y to the 9/3 and y to the 2/3. So the 3 squared is just 9. X to the 3/2 is just x. Y to the 9/3 is just y to the 3rd. And then you have left x to the 2/3 and y to the 2/3. But the x and the y both have a 3rd root in their exponent. So I can write that as the 3rd root of xy. And they both are still squared. And then in front of them you have 9x y to the 3rd power. So the answer to that question is this. Now let's try number 8. 4 square root of 72x minus 4 square root of 8x. So square root of 72 is 36 times 2, so 4 square root of 36 square root of 2x minus 4 square root of 4 square root of 2x. So both of them I broke apart, but the square root of 36 is easy to do. However, though, first let me factor out the square root of 2x. So the square root of 2x factors out. Then I'm left with 4 square root of 36 minus 4 square root of 4. But the square root of 36 is really 6, and 4 times 6 is 24. And the square root of 4 is 2, and 4 times 2 is 8. So that's really 8. So it's 24 minus 8, which is really 16, times the square root of 2x. And they normally write the square root after the number, so the answer is going to be 16 square root of 2x. Now let's try problem number 9. Problem number 9 says cube root of 81x to the 4th minus cube root 24x. So I can break apart the 81 into 27. I can break apart the x to the 4th into x cubed. So I'll have the cube root of 27x cubed. But then I'll still have left over the cube root of 3x, because I have 3 left from 81 and x left from x to the 4th. So then I have this. The 24 I can break apart into 8. And that will leave me with 3x left over. So the cube root of 27 is 3. The cube root of x cubed is just x. So I'm left with 3x. And over here, I'm left with this cube root of 8 is 2. And then I'll factor out at the end. The end is the same, so I'll factor that out. Cube root of 3x. So the answer is 3x minus 2 times the cube root of 3x. Now, let's try problem 10. So problem 10 says the fifth root of 128, x to the 13th over y to the 10th. So what I'm going to do is break this apart into what I can do. So there is a fifth root of 32. So expand this out into the fifth root, 32. There's also a fifth root of x to the 10th. Then there's also fifth root of y to the 10th. But then what's left over though, what I can't do the fifth root of is the 4, because 4 times 32 is 128. And then the last three x's, so x to the third, I cannot do the fifth root of that. So the fifth root of 32 is 2. Fifth root of x to the 10th will be 10 divided by 5 is 2, so it'd be x squared. And then the fifth root of y to the 10th is y squared. Then you still have left over on the side of it, the fifth root of 4x cubed. All right, now let's try number 11. So number 11 says the square root of 64x cubed divided by the square root of 4x. So it's all in a square root, so I can join the square roots together as 1, because you have a factor on the bottom and top. So the 4 goes into 64 and leaves you with 16. And the x goes into x cubed and leaves you with x squared. And then the square root of 16 is just 4. And if x is positive, the square root of x squared is just x. So you get 4x. Then number 12. 12 says square root of 7 times, parentheses, 9 square root of 14 minus 6 square root of 7. So if I multiply the radicals together, I'll get 9. Now, by the way, there's really an invisible 1 in front of this. So you're actually doing the 1 times 9, which is 9. Then the square root of 7 times the square root of 14. That would be 98. Minus, then the 1 times the 6 is 6. Square root of 7 times the square root of 7 is the square root of 49. And then you can break apart the 98 into the square root of 49 and the square root of 2, because 98 is 49 times 2. And then the square root of 49 over there. So you can factor out the square root of 49 to the end, and you'll have left 9 square root of 2 minus 6. So the square root of 49, that was really 7. So you'll get 9 square root of 2 minus 6 times 7, which if you multiply that back together, you'll get 63 square root of 2 minus 42, which is the answer. Now, let's try problem 13 on the review. So 8 square root of 6 plus 8 square root of 7, parentheses, times square root of 6 plus 7 square root of 7. And that times that is equal to 8 square root of 36. That times that is equal to 56 square root of 42. That times that is 8 square root of 42. And this times this is 56 square root of 49. But the square root of 36 is really 6. So you have 8 times 6. And then these two are common terms. So you have 56 plus 8, that's 64, square root of 42. And then the square root of 49 is 7, so you have 56 times 7. So then you get 48 plus that plus 392. Then combine the 48 and the 392 together. So A plus that would be 400 plus 40 is 440, like A 440. 64 square root of 42. There we go. Now number 14 on the review, it says 7, square root of 7, plus square root of 3, those are two nice prime numbers, squared. So when you square a group of two things in a binomial, you square the first one, you just get 7. When you distribute the 2 together, so 2 times that would be 2 square root of 21, and then you square the last one, which would just be 3. Then you combine the like terms, so 7 and 3 together is 10. So you get 10 plus 2 square root of 21. Now let's try 15. Square root of 23 over x, and we're supposed to rationalize the denominator. So I need to multiply the bottom of it by another square root of x and the top of it by another square root of x. So on the top I get the square root of 23x together, those can join together. The bottom of it, I'll get the square root of x squared. But assuming that x is positive, the square root of x squared is just x. So the answer is the square root of 23x all over x. Then let's try number 16. So number 16 says 4 over cube root of 11x squared. Now I need to multiply this by something to make 11 into a perfectly cubable number. So how about if I multiply it by cube root of 11 squared times x? Because then what you get is you get on the top 4 cube root of 11 squared times x, and on the bottom you get cube root of 11 times 11 squared is 11 cubed, and x squared times x is x cubed. But the cube root of 11 cubed is just 11. The cube root of x cubed is just x. So you get 4 times the cube root. Okay, 11 squared can be simplified to be 121. So we get 4 cube root of 121x all over 11x, and that's been rationalized in the denominator. That's all for the test 7 review for you. Very best wishes to you for your success.